Jamie. I'm a data scientist here at the Institute of Social Research. I work with the D3 Center. So the title of my presentation today is Data Curation for Micro-Randomized Trials in Mobile Health, Vignettes from the Mobile Assistance for Regulating Smoking Micro-Randomized Trial. So what will we cover today? A couple of things. Let me first provide the conceptual foundations. One, I'll talk about a brief overview of what a just-in-time adaptive intervention is. I'll also talk about the MARS study, what the purpose is, what the design is. I'll give a brief overview of what a micro-randomized trial is. I'll also talk about data structures, and I'll give 2 vignettes, which are an illustrative preview of challenges and solutions that we've encountered as we've curated data from the study. And we'll leave time for Q&A in the end. Okay, so let's get started. What are just-in-time adaptive interventions? Well, they are a special type of intervention, and interventions come in many different shapes and sizes. And adaptive interventions are motivated by the idea that interventions that provide the right type, intensity, and dose of treatment, and only when treatment is needed, will lead to better health outcomes. So if a just-in-time adaptive intervention, or JEDI, is a special type of adaptive intervention, what differentiates it from other types of adaptive interventions? Well, it is primarily differentiated in the rapid adaptation of the intervention. And rapid adaptation means that the adaptation can be performed weekly, daily, several times a day, or even several times an hour. So now you might ask, when might rapid adaptation be beneficial? Well, I think the answer to that question can be captured metaphorically with the 2 pictures that you see on your screen right now. So now you see the man in a paddle boat. That's an example of slow adaptation. The winds and waves in that river are quite gentle. So the way he assesses risks and opportunities are much slower compared to the picture that you see on the lower right hand of the screen. There, some friends are doing whitewater rafting. So their assessment of the risks and opportunities in that river has to be really quick. So let me have another point of contrast. When can slow adaptation be beneficial? So for example, maybe you might think about a reading comprehension curriculum that some 9-year-old students will go through for one entire academic year. Well, in that scenario, you might not want to tweak or adapt that curriculum in the middle of the school year, but you may want to simply assess the student's progress at the end of that school year and adapt after the school year has ended. So this is an example of when slow adaptation might also be desired. But for this talk, we'll be focusing on the situation where rapid adaptation can be beneficial. Okay, so our motivating study is the Mobile Assistance for Regulating Smoking study. So the reference is down there. The protocol for this study is published at the Journal for Contemporary Clinical Trials back in 2021. So this study enrolled 112 cigarette smokers attempting to quit smoking. And each participant was loaned a mobile phone with a smoking cessation app. So remember, we talked about rapid adaptation and slow adaptation. In the context of this study, rapid adaptation could potentially be beneficial because the risks of relapsing back into regular smoking habits and opportunities for a participant to be receptive to intervention can change daily or even hourly. So for example, if a person was stressed, it may not be the best time to intervene because they might not be receptive to the intervention that you plan to give them. But remember that stress can fluctuate quite rapidly over the course of a day. I might be stressed in the morning between the hours of 8 to 10 a.m., but maybe after I've had lunch, and I've had a really good lunch. By the time 2 p.m. Comes by, I'm not stressed anymore, and maybe that would be a good time to intervene. Okay, what's special about the mobile assistance for regulating smoking study is that in the study, we have a 10-day micro-randomized trial. Now, using the smoking cessation app, participants were randomized to 3 intervention options. 1, a prompt or a push notification recommending an effortful self-regulatory strategy. They got that 25% of the time. Another one is a prompt recommending low effort self-regulatory strategies. They got that 25% of the time, and no prompt or none, and they got that 50% of the time. So I've used the term micro-randomized trial. Well, let's talk about that here. A micro-randomized trial is a type of experimental design. And a defining characteristic of micro-randomized trials, or MRTs, is that randomization happens in the tens, hundreds, or even thousands of times during the entire course of the study. Now, what is the purpose of an MRT? The purpose of an MRT is to develop an optimized just-in-time adaptive intervention. Okay. In the MARS study, participants were micro-randomized 6 times a day for 10 days, which led to as much as 60 randomizations for a single participant. So on the right is a schematic of the MARS MRT zoomed in one typical decision point. So when we say decision point, it simply refers to a point in time when an intervention decision is made. So in this case, possible decisions are 1, low effort prompt, 2, a prompt recommending more effortful self-regulatory strategies, and 3, no prompt or none. And it is hoped that the prompts will lead to engaging in self-regulatory strategies and in the long term lead to cigarette smoking cessation. So on the left-hand side of your screen, you can see an example of what a prompt recommending low effort self-regulatory strategies would look like. It would look like the quick tips that you see. So here, the message, if you see other smokers, remember that you're a non-smoker now or get some fresh air. You're in control. So that's an example of a prompt recommending a low effort self-regulatory strategy. Notice that it's quite brief. It doesn't require a lot of time or effort from the participant compared to the image that you see at the center of the screen, which prompts the participant to try mood surfing. So notice what's displayed on the screen. It says, imagine yourself riding a wave. Simply be aware of the wave's movement, rising, rising, rushing away. And it also talks about an exercise that participants can practice to help them manage stressful thoughts or emotions. So as you can see, it requires more time to accomplish compared to the prompt on the left. Okay, so let's continue to talk about the design of the MARS MRT. What sort of data are collected in this study? Okay, so here is a schematic that's zoomed in to capture data collected near a typical decision point. Okay, what happens before that big R? So on your screen, that big R represents or denotes micro-randomization. So what happens before that big R is a really, really short survey is presented on the mobile phone. That survey has 2 questions that collect information on whether cigarettes are available and whether the participant is experiencing negative affect. So super short, just 2 questions. Now, after the micro-randomization, approximately an hour after that, an ecological momentary assessment, or EMA, is delivered. So the ecological momentary assessment is longer and has a lot more questions compared to the brief survey. The primary proximal outcome of this trial is collected in the ecological momentary assessment. And it involves questions that ask participants to report whether in the past hour they've utilized any self-regulatory strategies. Okay, so to summarize, we have here what I will call a block, and within each block at the start, a brief survey happens. Approximately a few minutes afterwards, microrandomization happens. Approximately 1 hour after the microrandomization, an ecological momentary assessment, or EMA, is delivered, from which we obtain our primary proximal outcome for this study. Let's capture what happens in a typical day. So the first, what I would call burst of events involving the brief survey, microrandomization, and EMA, that was scheduled to happen 30 minutes from a pre-programmed wake-up time. Now, this pre-programmed wake-up time was agreed upon by the participant and the study coordinator, typically by their first visit and before they begin, before they kind of start doing the microrandomized trial on their own. And the subsequent 2nd through 6th bursts of the day were scheduled to happen every 2 hours and 20 minutes or 140 minutes after after each dot here, as you can see on the screen. So in all, a day is approximately 14 hours long. So if you think about the data collection protocol is actually quite intense for this microrandomized trial. Okay, in trials such as this, aims are typically specified ahead of time. So in fact, the aims, the primary and secondary aim of this trial is pre-specified in the paper I referenced earlier in the slides. The primary aim of this study is to test whether, on average, prompting versus no prompting with a recommendation to engage in self-regulatory strategies will lead to more proximal engagement in self-regulatory strategies. Okay, and when I say proximal, really what we mean is conceptually short-term engagement in self-regulatory strategies. If you ping someone with a message, with a recommendation to engage in the next hour, are they likely to engage in self-regulatory strategies? Okay, the secondary aim is to test whether, on average, a prompt recommending a low effort versus a more effortful self-regulatory strategy will generally lead to more proximal engagement in self-regulatory strategies. Okay, so let me take a little bit of a segue and talk about this footnote here, eligible for microrandomization. In the study, whether or not someone was microrandomized at a particular decision point was restricted. The rule is quite complex, but one example of when microrandomization was restricted was, for example, when someone was driving. And when someone was driving and that was detected by the software, microrandomization didn't happen. Okay, so now we're slowly moving from the concepts of just-in-time adaptive interventions, MRTs, the motivating study, which is MARS, and now we're moving on to data structure. Okay. Now, the study design feels like there's a lot going on, but the structure needed for the data set that will be used for the primary and even secondary aims analysis is actually very simple. We need a couple of variables: your primary proximal outcome, an indicator for whether someone was eligible for microrandomization, denoted by your IJ here, an indicator for whether the brief survey was completed, and indicators for the randomized assignment. Okay, so let's go into more detail and more concretely what that looks like. So here is fake data, and I'm showing you a simple data structure for the primary aim. So notice the first column is your typical user ID or participant ID. day, what block it is, and your indicator for whether the short survey was completed, the time at which it was completed, whether or not the individual was micro-randomized to receive any type of message versus any type of prompt versus no prompt, the time the micro-randomization happened, whether or not they reported engaging in any self-regulatory strategies, and the time when they completed the EMA. So there's nothing scary about this. It's actually quite simple. But here's the kicker. In order to arrive at a simple data structure such as this, that's good to go, all set for data analysis for the primary aim, it actually requires a data curation approach that takes into account at least two things. One, the idiosyncrasies of the different data sources, and there are multiple data sources. And two, the nuances of the complex study design. Okay, so let's take a quick pause, look at our mile markers. If any of you are into running trails, where's our mile marker? Okay, so we've talked about JEDIs, the motivating study, MRTs, the data structure. So now we are moving on into the two vignettes, which are an illustrative preview of challenges and solutions that we faced in the data curation process for the primary aim. Okay, here's the first vignette. Okay, let's talk about the challenges that we faced in constructing the primary proximal outcome for this study. So one challenge was that the EMA responses and the timestamps associated with the EMA responses are stored or represented in atypical file formats. So for example, imagine a CSV file, and within each row of a CSV file, a JSON object was embedded. And each JSON object had a nested structure which corresponded to one EMA. So here I'm showing you what a typical JSON object looks like. So as you can see, it looks like a crosswalk, right? You have article ID, a semicolon, and the actual value. You have the article link, semicolon, the actual value. But in this particular data set, we don't, but in this particular data set, imagine this particular JSON file looking like something like this, as you can see in the box in green. So it's been flattened, so to speak, and one row in a particular CSV file would have something that looks similar to this. Okay. So now question. How do we go from this particular box here in the middle? What intermediate steps? So that's where the question mark is. What are the intermediate steps that we can take to go from this box here all the way to this really nice and clean format that we see down here, right? So that's one question. So as you can see, the box down here is in the typical format that your typical regression software in your favorite statistics package can recognize, right? Whereas here, the box in the second box here in the middle is not really in a form that your typical statistics package, your typical software can recognize. So what's that question mark? Now, there are many ways to approach this. One approach that I took was to use the R package tidy JSON. Tidy JSON is part, to use the R package tidy JSON, which is part of the tidyverse. Okay, so what does tidy JSON do? So it takes in a nested JSON object, and by simply calling one by simply calling one function called spread out, it leads to a nested JSON object that is formatted in this rectangular data set, which now your typical statistical software can easily recognize and work with. The kicker, though, is that the nested JSON object that this particular package takes in, so that it can simply kind of carry out this one function call, needs to be formatted appropriately. So that's just the kicker. It just needs to be formatted appropriately. And that means that double quotes, and this is really getting down to the nitty-gritty of things. Double quotes need to be placed in the appropriate locations, right? So recall, the second box here does not have double quotes right off the bat. So you need to have a step wherein you would include double quotes here so that this is something that tidyjson can read in and give you this rectangular data set that your typical statistical software can easily work with. Okay, so let's move on to the next vignette. This next vignette is about developing a decision rule to infer the originating block of each microrandomization. Okay, so let's tear that apart. What does that mean? So remember earlier I showed you the schematic that zoomed in these these sequence of events, what happens before a microrandomization, what happens after a microrandomization. All right, so the raw data that I was working with was actually a log file. And for some of you who are familiar with log files, again, it is not in a format that commonly used statistical software can easily use right off the bat, and it requires steps in between to get data from the format it is recorded or represented in a log file into a format, into your typical rectangular data set format that many statistical software expect or need. Okay, so the issue was that for the analysis, I had wanted to match each microrandomization to the appropriate block that it happened. Okay, so remember, in any given day, in a day, the study was designed to have six blocks. And imagine in the data that you don't have the actual block number, but block number corresponding to the microrandomization, but what you have is the timestamp at which the microrandomization happened. Now, what we do have in the data are for this brief survey, in that same log file that I was working with, that same log file also had a timestamp for when this brief survey was delivered, but also that log file contained the actual block number that brief survey was delivered. Okay, so here is the conundrum, and here's the question. So the most obvious rule is to simply match up. Whenever a 2-question survey was delivered, let's simply match up the time at which microrandomization happened, and let's just take the closest microrandomization in time. So the question is the most obvious rule, the one that I mentioned, necessarily correct? Okay, the answer here is trust but verify, and do a sanity check against the study design and be ready to revise. Okay, and the reason that I say that is one of the quirks that we've observed in this study was that, okay, remember, each day can be as long as 14 hours. And it was possible that this so-called wake up time could be later in the day, say for example, perhaps between 10 a.m. to 12 noon, for instance, just hypothetically for the sake of example. So that would push back the last burst here to be potentially after midnight the following day. Now the quirk also in this data set is that the wake up times are not necessarily the same across all days. So you might have one day where the wake up time is later in the day, but coincidentally in the following day, wake up times could be earlier in the day. So conceptually, you could think about, well, does that mean the latter blocks of the current day can overlap with the blocks in the following day, right? So just thinking through that logic, and again, why is it trust but verify? In that scenario, if that actually can happen, the most obvious rule of just simply doing a match between the closest time when micro-randomization happened and when the 2-question survey was, when the quick survey was completed, it's not obvious that it's necessarily correct. So long story short, I won't go into detail, but the takeaway from the second vignette is that the most obvious rule can be correct, but always refer back and check back against the study design and just be ready to revise your underpinning assumptions. Okay, and that finishes this presentation.
Wow, that was awesome, Jamie.
I'm wondering, like, if the software can detect driving, why can't the software detect wake up time and schedule the first intervention after, on an increment based on actual wake up time, based on data collected from like a smartwatch?
I don't think the question of can it, I think the question is, should we?
Okay.
For this particular study, yeah, I think it goes back to some of our discussions, of our past discussions in MDEN, when you think about something as conceptual as wake up time, for example, how do you operationalize that, right? Is it the moment I switched on my phone from when it was switched off? Or is it the moment when my phone was switched off, but I received a ping saying, hey, we're happy that you're in the study. Now is the time to begin data collection for today. I hope you're feeling great. Please press, and they receive some kind of push notification early in the morning. So does that constitute when they wake up, when they somehow interact or press the button or something like that with a push notification? So I think to answer your question, it can be done, but the moment it's implemented in the software, you are selecting a particular operationalization for how wake up time will be, right? So in this case, even if it's not pre-programmed in the software, the study designers did select a way to operationalize wake up time. And that way is for the participant to tell us before the 10-day period starts what their expected wake up times will be.
Thank you. And what software is used when you were saying the software can be programmed, like what software are you referring to?
Yeah. The Mars study is the fruit of a very big collaborative team. We have collaborators at the University of Memphis and the University of Utah, and in addition to us here at the University of Michigan. And the software is actually developed by some of our collaborators.
Hey, Jamie, it's Rima. I just want to say I really appreciate the decision point of like wake up time versus driving and why you guys handled it that way. I feel that, you know, we've talked as a group previously about this idea of big brothery, right? Like it is kind of intimidating to be part of a study like this. I feel it gives people a level of agency to say, tell me prospectively when data collection should start. And so it feels a little bit less intrusive, whereas driving is safety. I mean, that is a safety metric. And I think people can accept the fact that data collection would not be prompted when it is unsafe for you to participate. So I definitely, I like the decisions made to both respect, in a sense, people's privacy, or at least again, to give them that level of agency, and then also, you know, add the safety element of the driving sensing. I think that's on point.
Thank you, Rima.
Jamie, I do have a question. So for the data cleanup portion, you know, for converting all those JSON and files and pulling it out, do you ever consider like doing that outside of R, like maybe using like a data pipeline software or Lua or JavaScript, you know, something that can handle JSON natively?
Short answer is, for this project, short answer is no. But that's not to say we you know, we can't consider it for future projects, but that's the short answer. Yeah.
Okay.
Yeah.
I would love to see the test cases that your group put together to test your micro-minimizations. Just knowing how challenging it is when you're building online interventions, and how you want to make sure that you did in fact meet your specified plan. Like how long was the testing for this project?
Yeah. You know, yeah, it's such a great point. And I feel like even our team, we are growing in that area as well. One of the concrete things that we did was when the first 3 participants, you know, we had 3 participants kind of come in the study, and after 3 participants were recruited in the study, recruitment was paused momentarily.
Gotcha. Yeah.
And at that point, I did some checks. So for example, based from that check, I found that although we had, although the study was to deliver 6 ecological momentary assessments per day, we've found that there was a systematic bug that actually prevented the very last EMA from being delivered for these participants. So, so I wholeheartedly agree with you, like a check before you have your entire cohort of people in is super critical. Also, I think from personal experience, being able to use the software yourself was incredibly helpful to understand
Right. Yeah.
the nuances of, you know, when I receive the data. So it's not all numbers to me, that there's a story behind it, right? And one of the things that I've done is to actually loan the actual study phone, and, you know, take it for a test drive and see, okay, if I did this particular configuration of actions, for example, how would that manifest in the data, right? And like me, Jamie, that I actually created my own Jamie data. So there's like this crosswalk, so I know, Gabriel, you've been talking about like code books and crosswalks. Now, one idea is actually you generate fake data wherein you do a set of particular actions with that smartphone, and that can be a conceptual crosswalk between this is how the data manifests, right? So that's something that could be done also.